So for number 14, we're doing what we did with the previous number with 13, and we're trying to find now a false conditional sentence, right? For which the converse is true, the converse is false, the contrapositive is false, and the contrapositive is true. Now, I've put in here the truth tables for the conditional, so if P, then Q. For the converse, if Q, then P. And for the contrapositive, if not Q, then not P, right? And we can see from these truth tables that the conditional is logically equivalent to the contrapositive because they have the same truth table. Now we're looking at the case of a false conditional statement. So the only way that we're going to have a false conditional statement is in this row over here, right? In the second row. And the only way for us to get there is if P is true and Q is false. So for A, we want one where the converse is true. Well, if the conditional is false in the only scenario, then the converse is always also going to be true, right? As we can see in this row. And it's the scenario where P is true and Q is false. So let's set this up. We have to say that P is true and Q is false. So if spiders are I'm going to put it, if spiders have 8 legs, which is true, then 1 plus 1 is equal to 3. So we can see here that P is true and Q is false, and therefore our conditional is false, but our converse is true. Let's do item B, where the converse is false. Well, it's not possible, right? Because in the only combination where the conditional will be false, it necessarily means that the converse is true. So because for the conditional to be false, P has to be true and Q has to be false. So when we flip this around for the converse, the antecedent will be false and therefore the converse is true. So we're going to say not possible. Now for C, we have that the contrapositive is false. So once more, in this row, because the conditional is equivalent to the contrapositive, whenever P is true and Q is false, the contrapositive will also be false because it's equivalent. So we just have to give a true statement for P. So I'm going to say if 7 belongs to the set of real numbers, so that is true, then what can we say? Then 10 is irrational, which is false, right? So we gave an example that if P is true, then Q is false. So the conditional and the contrapositive are both going to be false. And for D, we want where the conditional is false, but the contrapositive is true. Now, we've seen that the conditional is equivalent to the contrapositive, and they have the same truth tables. So there's no way that the conditional could be false and the contrapositive could be true, or vice versa. Whenever the conditional is false, so will the contrapositive be. So that is not possible.